Yeah, worksheet yesterday dealt with Z tables and working through the Z tables. It was just a lot of practice in regards to drawing your bell-shaped curves, getting used to this table here, how you find your values in the table, and then once again calculating a probability or calculating an area. The probability and area synonymous with each other. So when you deal with the front side, you're calculating area. You deal on the back side, you deal with probability, but you're basically doing the same thing. Questions, anything in regards to the usage of the Z table, working through the Z table at all, finding values of the Z table? Any questions that you have? Once again, as I talked about yesterday, what I should see or what you should see in each one of those problems is you should see a bell-shaped curve. There should be a line and a bell-shaped curve. Draw in your lines and your values that you're working for, pull the values from the table, and make your evaluations that you need to, specifications to the problem. Things you need me to go through. All right, we will continue using that Z table. So you're going to want to have that Z table out. It's something that we will use throughout the rest of this chapter and into the next chapter. We won't use it quite as much because we will start working with a different type of table. And that will make life a little bit easier on us. But for right now, we're just looking at the Z tables. Okay, and what we're going to do today, the only difference to what you did yesterday to what you did today is on all your worksheets that you had yesterday, I gave you the Z values. And you had to look up that Z value and do your bell-shaped curve. What we're going to do today is you are going to now develop that Z value, and then through the use of a problem, determine what am I doing? What am I doing like on the back side? The probability that Z is greater than this value, or Z is less than this value. What you're going to have now is you're going to have the probability of a Z value, but you're going to do the calculations of the Z value. Now remember, when we're talking about a Z value, your Z value is calculated by value minus mean divided by standard deviation. Value minus mean divided by standard deviation. That's how we calculate our Z value. The mean salary for teachers in their first year is $28,200. If the distribution is normally distributed, with a standard deviation of $3,000, what percent of salaries are going to be below $29,200? What percent of values will be below $29,200? So what we have here is we have the mean salary of $28,200. We have a standard deviation of $3,000. And the first question I ask is, what percent of salaries are below the value 29,200? So the value that we are looking for here is 29,200. And we want to know how many are below this value. So the first step that we have is we need to calculate a Z value. So we need to calculate a Z value for this 29,200. And how we calculate our Z value is value minus mean divided by standard deviation. So we have this 29,200 minus the mean, which was given to you as 28,200, divided by a standard deviation, which is 3,000. So what you want to do is calculate this value, and you want to round to the nearest 2 decimal places, because our table goes to 2 decimal places. So you want to, if you're going to type it in, you want to quantify parenthesis 29,200 minus 28,200 end parenthesis, then divide by 3,000. Okay, so what do you come up with? Or you can just take the top 29,200 minus 28,200, hit enter, and then divide by 3,000. 3.33? Should be just 0.33. Because this will come down to 1,000 divided by 3,000. Take the 29,200 minus 28,200, hit your enter sign, then hit your division sign by 3,000. You should get 0.33. So what we are looking for here is we want to know what's the probability that our z value is less than, because we want to be below 29,200. So to convert it back into what we were talking about yesterday, we're looking for the probability that our z value is below 0.33. So now we're into a problem that we did yesterday. Draw your bell-shaped curve. Put your 0.33 value in there. Put your 0 in there, put your 0.33 in there. Go to your table value, find your table value, which gives us our value from 0 to that z value. Joey, what do you get for the table value? 0.1293. And since the problem asks us what percent is below, we want to know this value right here. What's our area below this value? Well, what am I going to have to do to calculate this entire area, Adam? I want to calculate this entire area here.
You'll have to add 0.5 to it.
Add 0.5 to it. 0.5 plus the 0.1293. So we have 0.6293, or 62.93% of the values. Or 62.9% of the salaries are below that specific value, theoretically. We want to find the percent of scores that are between 26,000 and 30,000. So we need to calculate a z value for 26,000 and a z value for 30,000. And we want to be in between these two z values. So calculate those two z values, check your answer with somebody around you for both those z values. Draw your bell-shaped curve. Get the z values. written down on the bell-shaped curve. And you want to calculate the percent of values, or the area in between those two Z values. You should get one Z value that's positive, one Z value that's negative. You want to find the area that's in between those two values. Alex, what do you get for the Z value for 26,000?
Negative 26.73. Or 0.73.
0.73? Okay, what do you get for your table value then?
Negative 26.73. Or it's positive, but
For what's your table value for 0.73?
26.73.
So if I look up 0.73, if I put 0.73, what's your table value? 0.2673. That's my first table value. Grayson, what do you get for a Z value for 30,000?
0.6.
0.60?
Yes.
What's your table value?
0.2257.
All right, we good with those? Okay. Once again, we're just finding z values, then we're going to our table and finding values from the table. So 0.60, 0.2257. Okay, so I want to calculate my percent of scores that are in between these two values right here, which means I'm just trying to calculate the area between those two values. What should we do to calculate our area? Nick, what should we do to calculate our area? Add them together. 0.2673 plus 0.2257, and what do you come up with? 0.493, so we have 49.3% of the salaries. Or at least close to about half the salaries are in between those two values. Once again, this is theoretical. These are all prediction things. We look to predict. We'll just do one of these. A survey found that people keep their microwave for an average of 6.2 years. I don't know what world that's in. I know I've had ours for 15 years. But on average, 6.2 years, standard deviation of 0.75. Okay, we'll look at just more than 8. Okay, we'll just look at that more than 8. Okay, we have an average of 0.62, I'm sorry, 6.2. We have a standard deviation of 0.75, and we're going to look at a value of 8. And we want to go more than this value of 8. So we want to calculate a z-score for this value of 8. So go ahead and calculate your z-score for the value of 8. Once again, value minus mean divided by standard deviation. Calculate your z-score. Go to your bell-shaped curve. More than 8, 8 is greater than the mean, so it's going to be a positive value. So get your z-score, find your table value. And we want to go more than the value of 8. So we want greater than that value of 8. So that's going to be greater than that z-score. So I have what to give for your z-score? 2.4. And then your table value? 0.4918. 0.4918. Good with that? Everybody find that? Go to 2.40, 0.4198, 0.4918. Now we want to be more than, so we want to be greater than, so we're looking for this area right there. So Jace, what are we going to have to do to calculate that area?
Subtract 0.5.
So we have 0.5 minus 0.4918, and we come up with what? So we have 0.82%, 0.82 probability or percent of microwaves that they keep after 8 years. Once again, I don't know where they came up with that survey, but that is something they came up with. Nothing, only thing that's different from what you did yesterday to what you did today was now you're making that next step and you're calculating the Z-score. What we are assuming that we have normal distribution. We are assuming that we have normal distribution with our data values. That's what we are assuming, that you have a normal distribution, which means you have no skewness. Question is, how do we check for skewness? If we have a set of data, how do we check to see if it's skewness? Other than the eye test, you go, okay, yeah, Bill Gates is going to skew the average salaries here in down local school district. That's the eye test. But how can you mathematically prove that it does? Well, there's a value called the Pearson's index. The Pearson's index is you can calculate Pearson's index as our mean minus our median divided by our standard deviation, and you multiply that by 3. This is called the Pearson's index. Type that and get that out of there. If the Pearson index is greater than 1 or less than -1, that can be concluded the data is skewed. If you're greater than 1 or less than -1, you're going to have skewness. In addition, you also have to take a look at outliers. There's a lot of things that goes into skewedness. You have outliers. Outliers are going to skew data also. Now, and the outliers are calculated by 1.5 times the interquartile range if you lie outside 1.5 the interquartile range, above the upper quartile and below the lower quartile, then you have outliers. Now I know this is a gauge for outliers, or a gauge for skewness. If your Pearson index is between -1 and 1, no outliers exist, you can conclude that we have approximately a normal distribution, which means I can use a normal bell-shaped curve. Which means you can go to your z-table. Now this is where your things start to get into a judgmental zone. You start making judgments here by the person that is doing the observation or experiment. If your Pearson index lies outside that range, -1 to 1, but it's like barely outside that, but you still have no outliers. Say you get, and this is a difference between, once again, mathematicians and statisticians. Mathematicians, we follow rules. There are rules to mathematics, how you do things, and we follow those procedures. Statisticians, well, there's some gray area. There's some gray area, and that's okay. The Pearson index lies outside the range -1 to 1, but no outliers exist. You can assume the data is somewhat skewed. Somewhat. Now, it depends on how close you are to 1 and -1. And you have no outliers, you know what? I'm still good with using a normal distribution curve. And that's what statisticians will do. But if you lie outside that -1 to 1 and you have outliers also, you can assume a skewness. Because you can sit there and come up with situations. This is like what I talked about with probability. If you're outside that range of -1 to 1, I'm sorry, you're inside that range from -1 to 1. If you have an outlier here that's greater, on the greater side, and you have an outlier here that's on the smaller side, you have two outliers here, one on each side. When I start talking about the mean and median, that's going to be relatively the same. And that's going to give me a Pearson index between -1 and 1. So you start running into some issues there. Let's take a look at the Pearson index here, or a set of data values. What I want you to do is I want you to calculate the mean and the median. I'll give you the standard deviation real quick. So what do you get for your X bar and your median?
I got 50.3 for my
50.3?
Yeah.
And the median?
21.5.
21.5, median. I rank from least to greatest, 33, 41, 46, 48, 58, and 76. What's your median? 47? 47 is our median, our middle number. 47. So to find the Pearson index, we have 3 times the mean, 50.3, minus the median, 47, and I calculated the standard deviation to be 13.72. So we take 50.3 minus 47, multiply that by 3, and divide by 13.72. Melissa, what do you come up with? 0.72, which is in between that 1 and -1, which I'm good. If I look at outliers, here's my Q1, here's my Q3. My interquartile range is subtracting them. So we have 58 minus 41, which is 17. We multiply that by 1.5, which is 25.5. We add that to my upper quartile. Which is 58 plus 25.5, and subtracted off my lower quartile, 41 minus 25.5. So we have 83.5 and 1615.5. So that's, if I lie outside that range of values, I have an outlier. 76, by an eye test, sort of looks like, well, 33, 41, these are pretty low. 76 almost looks like an outlier. But it's not by our means here. So I have no outliers. I have a Pearson index of 0.72. So I could say this data here is normally distributed. Once again, the Pearson index is sort of a subjective value. As people talk about statistics and statisticians, they can make it look however they want to make it look. And that's why some people don't trust statistics sometimes. And when you have statistics that are thrown at you on TV by this newscast or this newscast or this group of people, you have to sort of take those statistics and go, okay, yeah, you're right in regards to that, but you've bent the statistics a little bit to make it prove your point. And that's what you have to watch out for sometimes with respect to statistics thrown at you on TV, whether it's this newscast or this newscast or this newscast. because they'll bend the statistics and make their case sold on how they bent the statistics. So you have to really watch what's going on with that. Okay, you have 3 problems here, but there's 3 problems within each 3 problems that basically are doing what we did on the first page here. You're calculating a z-score, you're doing a bell-shaped curve, and then you're calculating a probability of percent of scores that are in between or lower than, greater than a specific z value. All right, questions you have? Tomorrow we'll come in, we'll go over what's called the central limit theorem, which basically puts a little tweak in regards to how we calculate our z-score. But we're still going to be calculating z-scores. It's just going to be a little bit different look of an equation. And we're going to be doing the exact same thing tomorrow. And that will be the last of the material for this chapter. Gearing towards a quiz next week, at the end of the week next week. So that's finishes up chapter 5 come tomorrow. All right, questions you have?
All right, the rest of the time is yours.